This is the FG25 Pro Kit. This is the 915 megahertz version for Japan and North America. There are different versions for different regions. Opening up the box here. We have an antenna. We have a main board with a radio board. We have a Raspberry Pi expansion board, and we have a programming cable. Let's go ahead and open up the main board here. You can see the main board has a radio board built into it, or already populated onto it. So what we're going to do here is we're going to add this antenna onto the SMA connector of the radio board. And we're going to power this up. So one thing we're going to do is this power switch here selects the power for this main board, which we call the wireless starter kit. In the rightmost position, this is powering the radio board from the USB connector that connects to the PC. This is what we call the AEM mode, or Advanced Energy Monitor mode. This actually allows us to monitor the energy and helps you optimize your firmware for power consumption. So right now we're going to go ahead and plug it in to a PC. This is a Type-C cable. You're actually going to supply your own cable. We don't include the cable in the kit, but once you plug it in, you'll see the LEDs light up and you'll see the LCD screen indicating that it's connected to your PC. After we plug in our device into our PC, we're going to launch Simplicity Studio. And if you're in the launcher perspective in Studio, you should see something that looks like this. You can see here in the debug adapters that the board is recognized as an FG25 board. You can also see there's an option here to get started with this particular device. Now, if you don't have Simplicity Studio installed, you do want to go ahead and plug the device in anyways, and then install Studio. What happens is when Studio is installed and there's a device already connected, it will make sure that it installs all the drivers and everything needed to support that particular device. So you would plug in your FG25 Pro Kit and you'd launch Studio, or install Studio, and you let it finish and it should launch everything automatically. Here I already have Studio installed and it recognizes the device, so I'm going to click Start, and you can see here that it retrieves a lot of information about the device. One thing to note here is there's a preferred SDK. I'm going to choose the latest SDK, which as of right now is Gecko SDK Suite 4.2.2, so I'm going to choose that. You can see here that if I go to the Example Projects and Demos tab, there's a long list of example projects and demos that are built into Simplicity Studio that you could easily build and or flash your device with to kind of play with the tool, do demonstrations, and kind of see things working. So here you can see that there's a lot of Rail and YSUN demos already built in. And then there's also documentation here. So if I go to documentation, I can look at app notes, schematics and layouts, user guides, other things that are specific to the board that I have connected here. Coming back to the board to show you a few things, there is an Ethernet port on the board here. This allows you to connect to the board over Ethernet, and the Ethernet port supports the same features that the USB port supports. So that includes virtual COM port. That includes flashing and debugging the device. That includes packet trace for network analysis. That also includes the AEM, the Advanced Energy Monitor functionality. So you can access both of those, all those features from either the USB port or the Ethernet port. When you're plugged into Ethernet, your IP address will show up on the LCD display here, and that'll help you kind of maintain your test network. One feature we're going to show here is this is the wireless expansion board that comes with the kit. This header does not come pre-installed, so you'll have to solder that header on there. But what this gives you is this gives you connectivity directly with a Raspberry Pi. And the Raspberry Pi has an expansion header built into it already that has direct access to UARTs and SPI ports on the Raspberry Pi. And so this plugs directly into that. And then you can see here that the radio board mounts directly to the Raspberry Pi board. So once I mount this radio board to the Raspberry Pi board, now I can run applications on my Raspberry Pi directly connected to the board. This is really useful for YSUN border router. Obviously, border router runs on Linux, and so that allows you to run on this, run on this kit directly off of the UARTs that are on the Raspberry Pi. So one other thing, that this cable that's included with the kit, this is a programming cable that allows you to program your own target hardware using the main board. And so this just attaches to the lower right side of the board. There's a header there for programming. And all you have to do is, on your target board, all you have to do is make sure that you have the 10-pin mini programming connector. That's what Silicon Labs recommends. For more details on that, you can look at AppNote AN958. This is actually the same header that's already on this Raspberry Pi expansion board, so I can plug this into my Raspberry Pi board, and I can use this to flash from the main board. I can use this to flash the radio board that's on the Raspberry Pi expansion board, or do debugging or packet trace. There's all the functionalities available over this mini connector. So one other that we also have what's called the YSUN kits. The YSUN kit includes kind of what you see here. Obviously not the Raspberry Pi, but the YSUN kit actually includes 3 radio boards and 3 main boards. So essentially includes what you see here. Now, this is really useful because with YSUN, obviously YSUN's a networking technology. With 3 kits, you can make a network, so you can use one kit as a border router and then connect the 2 other kits as nodes to the border router, and you can run, throughput tests or application data, or whatever you want to do. This just gives you the ability to have all 3 nodes in one package. But that's really the difference between the YSUN Pro Kit, which has all 3 nodes, and just the FG25 Pro Kit, which just has 1 node. For this demo, we're going to create a demonstration YSUN network featuring the YSUN Network Performance application. To do this, we're going to make a border router. We're also going to make 2 nodes that use the Network Performance firmware, and we're going to use these tools to perform some network performance measurements. A reference for what we're doing can be found in Quick Start Guide 181, that's QSG 181, and also AppNote 1364 on the Silicon Labs website. And we're going to do this with 3 Pro Kits. You can see in the launcher view up here, we have the 3 FG25 Pro Kits connected right now. If you don't have Studio installed, go ahead and plug in one of the Pro Kits when you install Studio, and Studio will make sure that it has all the tools needed to run these boards if you have it plugged in during the install. So the first thing we're going to do is we're going to make sure that our preferred SDK is Gecko SDK 4.2.2, which is the latest as of this recording. We're also going to rename the debug adapters just to make it easier here. So the way we do that is right-click, rename. This one's going to be the border router. We're also going to have a server. And we're also going to have a client. The server and client are going to have the same firmware. Let's go ahead and find that now. So we're going to pick the demo for the SOC network measurement application, and I'm going to click run to flash the demo. So just a word about this. What the demo is it's actually pre-built firmware that's installed within Studio. So Studio knows about this firmware, and it just flashes the firmware into the device. This also includes a bootloader. So Studio, essentially the device will be ready to run once we do this demo. Let's go ahead and do the same thing for the client here too. Now, the SOC network measurement is also available as a project. So instead of doing the demo, you can actually pull the project in, build it, and then flash it. We're just saving a little time here by flashing the pre-built image, just so we can focus on the operation of the firmware itself instead of the build process for the firmware. So once this finishes, we're going to flash the border router. For a production YSUN application, your border router is typically going to be a Linux node. It's going to be running on Linux. In this case, what we're actually going to do is use one of the Pro kits as a border router. So we have a demo for this. We have the SOC border router demo, which I'm flashing right now. So this SOC border router demo kind of takes the place of the border router for the purposes of the demo. And you can use that in place of a Linux border router, just if you're focusing on the kind of behavior of the firmware images of the client devices that are connected here. And each one of the Pro kits has a virtual COM port that is connected to the FG25 that's on the board. So all we need to do here is go to the adapter and do launch console. We'll start with the border router. Go to serial 1, press enter a few times just to make sure the prompt shows up. We're actually going to start the border router here, and we're going to start it on the fan 1.1 default, which is a 50 kilohertz FSK. And so now we're going to go to the client and open a console here. Again, serial 1, make sure it's connected. Here we're going to, let's do YSUN join fan 1.1. You can see that it's starting to join now. And then we're going to go to server and do the same thing. And then we're also going to, let's organize these windows here so that we can kind of tile them and see everything going on all at once. So that took a few minutes. We jump forward here to see that it's done. So we see now that on the server side and on the client side, there are IPv6 addresses showing that the devices have joined the network. So on the server side, we're going to start an iperf server. So the command for that is iperf server. Okay, so now that's listening. On the client side, we're going to do an iperf client, but we need to point it to the server. So we're going to do iperf get options to show you the options here. So there's a remote address field here. So we want to set the remote address. So this would be iperf set options.remote adder. And then we are going to copy this address from the server. You can see the server actually timed out, so we're going to restart the server here, and then now we're going to start the client, iperf client. So you can see it's essentially sending data packets to the server, recording the bandwidth, and giving you some statistics on how many packets are lost. All right, so now that that's finished, one of the other things we can use with this firmware is we can do pings to test latency. So the way to do that is we already have the server address for the client, so let's just do YSUN ping. And then we'll paste the address. All right, so we can see that the minimum here was 210 milliseconds. We can try again. 215 milliseconds. We also have the border router address from the initial network creation. We can also ping the border router from the client here just to see. A shortcut for YSUN ping is just WP and then the address. All right, we see the border router is responding a lot faster than the node is. It's still around kind of 85 to 95 milliseconds here. So what's cool about this, we can actually explore how a different PHY would affect the latency. So what we're going to do here is we're going to restart our network using the OFDM option 1 MCS2, which is PHY ID 34, and then we can see how the ping results change on that. So the way we're going to do this is we're going to reboot our border router here. Just type reboot. Okay, and then we can do YSUN set YSUN PHY mode ID 34. Shortcut for YSUN set is W space S space YSUN channel plan ID 5. And we can do YSUN start fan 11. So it's restarting with a new PHY. So we also have to reconnect our clients with the new PHY as well. So the way we do this is we do YSUN disconnect. Okay, and then we actually we can do those same commands here. We can do, I'm just going to copy paste. So now I can do YSUN join fan 11. So I'm just joining with the new PHY here. We can do the same thing for the client. So again, that takes a while. We jump forward several minutes here so that both nodes are now joined with the new OFDM PHY. So what we're going to do is we're going to copy the server address here again. And we're going to YSUN ping that server address. You remember last time it was over 200 milliseconds. So now it's way faster. So you can see here that the minimum time now is around 20 milliseconds. I can also ping the border router. Let's go ahead and do that. So before, when we pinged the border router, it was about 80 to 90 milliseconds, and now it's kind of around 50 milliseconds. Well, there's a 35. Now it's down to 20. So you can see that there's essentially the ping times are way reduced now when we use the OFDM PHY, which makes sense because the OFDM PHY has a lot more throughput, and so that directly leads to lower latency on the connections.